Our last two objectives describe how the sample size and the confidence level affect the margin of error. Explain how practical issues like non-response, undercoverage, and response bias can affect the interpretation of a confidence interval. So there are two important cautions to keep in mind when constructing and interpreting an interval. Our method of calculation assumes that data come from SRSs of size n from the population of interest. Basically, it's assuming that the sampling method was good. The margin of error doesn't account for any type of bias because it all comes from a trustworthy or representative sample. So if it wasn't a representative sample, our margin of error can't account for any of that bias that could be included. Second, the margin of error in a confidence interval covers only chance variation due to random sampling or assignment. So that margin of error comes from this idea of sampling variability. So we expect that the samples vary close to the population parameter. And so that's where the idea of this margin of error comes from. And in the future videos, I'll show you how to actually calculate the margin of error. So bottom line is, other things being equal, the margin of error of a confidence interval gets smaller as the level of confidence decreases. So if we were 99% confident and we want to change and be only 95% confident, then our interval doesn't reach out as far. So if we're less confident, then our interval decreases in its width. And then finally, the sample size. If we increase our sample size, that's going to decrease the margin of error because it's going to decrease the standard deviation of the statistic. Back up to this picture here. Increase your sample size, this value gets smaller, which means the margin of error gets smaller. More on that in the future videos too. So our last example problem. As part of a project about response bias, Ellery surveyed a random sample of 25 students from her school. One of the questions in the survey required students to state their GPA aloud. Based on the responses, Ellery said she was 90% confident the interval from 0.4 to 0.72 captures the proportion of all students at her school with GPAs greater than a 3.0. Explain what would happen to the length of the interval if the confidence level were increased to 99. So if the confidence interval originally was 90%, and now she wants to go to a 99% confidence interval, that just means she's going to reach out an extra standard deviation. So the confidence interval would be wider. Again, the interval is wider because increasing the confidence level increases the margin of error. Last question, describe one potential source of bias in Ellery's study that is not accounted for by the margin of error. So in this case, the margin of error doesn't account for the fact that many students might lie about their GPAs when they're having to respond without anonymity. So the proportion of students with GPAs greater than 3.0 might be less than what she said, where she said she's 90% confident it's from 40% to 72%. But our margin of error can account for the fact that a lot of these students might be lying because they want to make themselves look better than what they actually are. Again, you can pause if you want to read this. I've got a couple of practice problems here that I'd like you to do that will refresh you on this content that we learned in this videos.